Okay, so this is a lesson on the derivatives of inverse trig functions, and you will have your quiz tomorrow is going to be on this, so you should be taking notes and you need to know this. So the good news is that there are actually 6 different functions, but the good news in this is that for AB they usually only use 3, so I'm just going to talk about 3 of them. Okay, so we want to find the derivative of an inverse trig function. So let's say the trig function is sine x, then we want the inverse of that, so it would be sine inverse x. And the question is, how would you take the derivative of that? Okay, so there are 3 formulas, and so if f of x equals sine inverse x, then f prime of x will equal 1 over the square root of 1 minus x squared. Okay, this is just a rule. This is all based on memorization. Okay, if f of x equals cosine inverse x, little minus there, then f prime of x is going to equal negative 1 over radical 1 minus x squared. So you can see the only difference between the two is that the one that goes with the cosine is negative. And the last one, f of x equals tan inverse x, the derivative is going to be 1 over 1 plus x squared. So notice these are both this is addition in the denominator, and there is no square root. So these are just 3 rules, and you just kind of have to know them. Okay, so now the next question you may have is, well, what if it's not just plain old x? So what if f of x equals sine inverse of x squared? Okay, then f prime is going to equal 1 over radical 1 minus, okay, so it was an x squared because we had an x, but this time we have an x squared. So it's going to be x squared squared times the derivative, which is 2x. So let's go back over that again. So the derivative of sine inverse of something is going to be 1 over radical 1 minus that something squared, that comes from here, the something squared, times the derivative of the something. So this would just end up giving us this. Okay, and the same thing would go for the others as well. So I'll put the cosine one over here. Okay, so let's say we had that f of x equals cosine inverse of 2x. Then f prime is going to equal negative 1 over radical 1 minus the something squared, so you can put parentheses there if you want, times the derivative of the something, and the something is 2x. So if you wanted to simplify that, make some room here, you would get a negative 2 on top, and on the bottom you could simplify, and you would get that. That would be your answer. Okay, and then of course the same thing is going to work for tan. Hope you're starting to get the hang of these now. And so let's say that f of x equals tan inverse of, let's live dangerously and say e to the x. Okay, then f prime is going to equal 1 over 1 plus e to the x squared times the derivative of e to the x, which is just e to the x. And if you wanted to simplify that, you could. And you would get that f prime equals 1 over, I'm sorry, not 1 over, because we'll put the e to the x on top. That will go on top. And then we'll have 1 plus e to the x squared, because remember there's a rule that says if you have an exponent over here, you just multiply them. I'm sorry, not x squared. Yes, x squared. You're multiplying them. X times to the second power is just x. Okay, and that would be your final answer. So how could this also be given to you? Well, what about integrals? So those were derivatives. So in all likelihood, you could get one of those. So of course we didn't do secant, cosecant, cotan. That would really be for BC. I mean, it could show up highly unlikely. So, so think about this. If f of x equals sine inverse x, and you know that f prime of x is going to equal 1 over the square root of 1 minus x squared. Okay, so we know that. So let's pretend we don't, though. If you were given the integral of 1 over this, what is the antiderivative of that? You're not going to be able to use substitution. There's nothing that you can do. So you should notice that it's the same as this. So what was the original? It would have to be this. Plus c. Okay, so that's what you're probably going to see on the AP test. So let me give you another one. Like, you'll end up simplifying something, and then you're going to end up with that. Like, maybe with the use substitution, that will simplify. So, for example, let's say you have some sort of use substitution, and after you simplify, you end up getting this. Okay, because you'd be using the u. Then you would have to recognize that that is one of the trig derivatives, and that whole thing would just equal cosine inverse of u plus c. Okay, so how can you remember these? You just have to memorize them, unfortunately. It's extremely annoying. Okay, so let's try one more problem, and then that's it. So, I mean, essentially it's a pretty easy lesson because there's not much more to talk about at this level. If you were in BC, it could get a lot more complicated, but it's just the memorization, and that's why I always save this for the very end, because it's pure memorization. So let's say you were given this, and you need to find the derivative of that. Okay, so the derivative of sine inverse of something is going to be 1 over radical 1 minus the something squared times the derivative of the something. So the something is 1 minus x squared, and the derivative of that is negative 2x. So if we write that nice and neat, we'll get this on the top, and on the bottom we'll get this. And that would be your answer. Okay, so if you want, you could go online, you can look up some examples, you could go to YouTube. I am positive that this is in your Princeton review book. You could try those problems, but tomorrow we'll have a quiz on one of these. Okay, and that completes that topic.